So in problem number 6, I'm not asking you to actually solve for the exact radian measurement, but actually rely on the unit circle, whether you're looking at the one divided into 12 parts or the one divided into our two special right triangles, and just try to figure out between what 2 radians should I expect the Ferris wheel to be 60 feet above the ground. Keep in mind that as the Ferris wheel goes around, it's going to hit a maximum a height of pi over 2, and then it's going to come back down, and then continue back to increase. So keep in mind that you have there are 2 answers or 2 places where the height should be 60 feet. So make sure you're giving approximations for both of those. So I'm going to move on to problem 7. It's asking you to draw a turbine, put in the critical measurements, and then what would be the highest and lowest height in terms of the blades, and then add that information to the drawing as well. So go ahead and work on problem 7 and 8. Turn the video back on when you're ready to continue. So for problems 7 and 8, you have a wind turbine. The height of it is 200 feet, and then the blades reach to 120 feet from that pivot point. So if we're looking at the tallest it can be, it would be 320 feet. It would be 200 plus the 120 feet for the blade. And then if I'm looking for the least height, I'm looking at the blade going straight down. It's basically at 6 o'clock on the clock, which means that you are 120 feet from that pivot point. So you'd subtract 200 and 120, and that would be 80 feet. So hopefully the illustration shows all of the information that they're looking for 7 and 8. Any questions you can always ask in the next class period, but let's go ahead and go on to problem number 9. So using our radian circle, we're looking at basically the peak's going to be at the top of the unit circle. So hopefully you indicated in radians that the height would be at pi over 2. That would be the highest. And then the lowest would be at the bottom of our unit circle, which would be 3 pi over 2. So the highest at pi over 2 on our unit circle, and the lowest would be at 3 pi over 2. Go ahead and take a look at problem 10, 11. We have the last 2 problems for the turbine. Turn the video back on when you're ready to discuss those answers. So what does the 120 sine of pi force represent? Basically, it's the vertical distance between the center of the wind turbine, which again is about that 200 feet, I believe, and to the tip of the blade when the angle is pi over 4. So again, it's basically where the pivot is, about 200 feet above, and the distance that from there to the tip of the blade at an angle of pi over 4. And then the last problem here is actually asking you for how high is the blade above. So you have the 200 feet, which is where the pivot is. That's where the blades are rotating. So you have about 200 feet plus the sine of 11 pi over 6. You have to keep in mind that the tip is 120 feet. So that really represents that's our radius. So the radius isn't 1. It's 120 sine of 11 pi over 6. So this is real similar to the problem that we looked at earlier. So the calculator. And the answer is, comes out to be exactly 140. And then for the last set of problems, relates to airplane propellers. So take a look at the problem. You're given some radians. You are told the radius is 3 feet, and then the center of that propeller is 13 feet high, it's 13 feet above the ground. So can you, again, figure out the answers and then turn the video back on when you're ready to continue the discussion. All right, so the answers are 14.5, 14.5, and 10. The pi over 6 and 5 pi over 6, those two propellers are pointing. This basically in like first quadrant, second quadrant, the same. They're both the same distance above the ground. The third propeller is pointing straight down. That would be basically 270 degrees. So you basically are subtracting the equation is an addition of 3 times sine 3 pi over 2, but basically you are reducing the height from the pivot by 3 feet, which is the reason why it's 10 feet above the ground versus being an increase from the 13 feet. The last problems are reviewing of transformations of functions, but in both cases you're given y equals x squared and you're being asked to use transformations to come up with where the new equation would end up at based on the numbers you're given. When you're finished, I turn the video back on and we'll finish up this handout. Okay, so for the first one of the conversations I will have about functions is what makes that x value equal 0. And that actually tells me how much I'm shifting left or right. So in this case, I'm shifting 3 to the right, since 3 minus 3 is 0. And then the second number, which is the addition problem 2, tells me that the equation or the graph is going to move up 2 units. So basically, instead of the vertex being at 0, 0, the entire graph is moving 3 to the right, 2 up. So the new vertex will be at 3, 2 instead of 0, 0. I went ahead and mark these the 5 points here because the a value, or the number in front here, the a value is 1, so that means the graph is not going up or any faster than it normally does. So if I count over 1 up 1, which would be this point from the vertex. So if I count over 1 up 1, that would be that point. If I count left 1 up 1, that would be this point. So from our new graph, left 1 up 1 would be this point. And then the other one would be if I count right 2 up 4, that's this point. So basically, if I count right 2, that's basically doing 2 squares, so my answer should increase 4. So I go 2 to the right of the vertex 3, 2, and up 4. That would be this point here at 5, 6. And same thing if I go left, 3, 2, left 2, up 4. I would be at 1, 6. This would be the graph for problem number 13. Now in problem 16, there is no parenthesis, which tells me the graph is not moving left or right, and there's no addition or subtraction problem to the right of it. That tells me that the vertex or the graph's not moving up or down. So that means this graph here is going to start at 0, 0, just like the original function. But the difference here is the a value is 2, which means wherever the answer is originally, now it's going to be twice that. So if I go over 1 up 1, the answer is, for 1 squared is 1. Now it's going to be double that. So the original function, the answer was 1. And then I put in 2, the answer is 4. I put negative 1, I got an answer of 1. I put negative 2, I got an answer of 4. Now with the new graph, because of the a value, I'm double it, everything is getting doubled. That means that the 1 is now 2, the 4 is now 8. And I'm doubling it. So if I go 1 to the right, up 2 the right, up 8, and 1 to the left, up 2, and 2 to the left, up 8. This would be the answer to problem 14 as a graph. So basically, the answers are, the graph's going up twice as fast as it did originally because all the answers are double what they were originally. So hopefully I was able to explain the problems clear enough to you so it was a good understanding. Maybe questions you can ask me on Thursday. Please use the remaining time to work on homework.